This is the Algebra 1 Summer School Unit 6 Lesson 1 practice video. This is the practice video for the problems that are attached to the notes file. I'm going to do numbers 1, 2, 3, and 4 for solving quadratics by factoring. If you have questions other than 1, 2, 3, and 4, you need to look at the key that's posted on Canvas or come into office hours and ask your instructor for help. All right, so number 1, the directions say to factor and solve. It says you can also check your solutions by graphing. All right, so number 1, we have x squared minus 36. When I look at this problem, I notice that there's two terms, so it's binomial, and there's a minus in between those two terms. So when I have a binomial with a minus in between, I use the method of difference of squares. I can use this difference of squares method because I can take the square root of x squared, which is x, and the square root of 36, which is 6. Because I can take the square root of both of those terms, I can use this difference of squares pattern. Factoring by difference of squares is two binomials. Each gets the x in it and the 6, and then one gets a plus and one gets a minus. So x plus 6, x minus 6 is the factored form of x squared minus 36. Now, in order to solve by factoring, I use the zero product law, which says that I take each factor of this factored form, I set it equal to 0, and then solve each for x. So I'm going to have that x equals negative 6 is one solution of the quadratic, and when I add 6, I got that x equals positive 6 is another solution of the quadratic. So that's number 1. For number 2, I have the polynomial x squared plus 12x plus 27. This is a trinomial with 3 terms, and the first leading coefficient is 1. To factor a trinomial, we look for a GCF. It does not appear to have one, so I'm going to use the method of split the middle. For split the middle, I multiply the 1 and the 27, and know that I need to find two numbers that multiply to 27 and add to 12. Those numbers are 9 and 3. Once I find those two numbers, I go ahead and I split the middle. Remember, the first term comes down in front, x squared. The last term, plus 27, comes down. And then I split the 12x up into plus 9x plus 3x. Once I've split the middle, now I group the first two terms together and the last two terms together. From each of these groups, I look for a GCF. It appears for x squared plus 9x that there is an x in common to both. That's its GCF. And when I divide that GCF out, I'm left with x plus 9. Now, in the second set of parentheses, the third term here is positive, which means that your GCF is going to be positive. The GCF between 3x and 27 is 3, which I'm going to divide out. So plus 3 is the GCF. When I divide that out, I'm left with x plus 9. The really nice thing about this method is you know if you're getting factoring correctly by if the two parentheses you're left with are the same. Because I have two x plus 9s, I know I did things right, and I can write my final factored form of x plus 3 times x plus 9. Now I'm going to set each of those factors equal to 0. So take x plus 3 equals 0, and x plus 9 equals 0, and solve for x. When I do that, I'm going to subtract 3 here and get x equals negative 3 as one of the solutions. And subtracting 9 gives me x equals negative 9 as the other solution to this quadratic. All right, looking at number 3, I have 3x squared plus 5x minus 2. This is also a trinomial that does not have a GCF. So I start again by multiplying the first term and the last term, which gives me negative 6. So I need to find two numbers that multiply to negative 6 and add to 5. Those two numbers are 6 and negative 1. Now I go ahead and split the middle just like the last problem by writing the first term first, the last term on the end, and splitting the middle with the two numbers that I just chose, the positive 6 and the negative 1. Now I'm going to group these together first two terms and last two terms in a group, and search for a GCF. The GCF for 3x squared plus 6x is 3x, which is what I'm going to divide out of both terms here. When I pull out a 3x, I'm left with x plus 2. Now from the second parentheses, this term is negative. So my GCF is going to be negative. And the only thing those two terms have in common are a negative 1. When I divide out the negative 1, I'm left with x plus 2. Again, just like in the second problem we did, it's a good thing that these x plus 2's are the same, because you can get the final factored form of 3x minus 1 times x plus 2. Once I factor the polynomial, in order to find the solutions, you again use the zero product law. So I'm going to set each factor equal to 0 and then solve it for x. So on the left here, I'm going to add 1 to both sides, and I'll get 3x equals 1. And then I'm going to go ahead and divide by 3. So your solution, one of the solutions, is x equals 1/3. My other factor, I just go ahead and subtract 2 and get x equals negative 2 as a solution. All right, last problem we're going to do on this practice. I have 20x squared minus 10x equals 0. Now, there is a binomial here, and there is a minus sign in the middle. But the difference between this and number 1 is that I cannot take the square root of 20 or 10. What I should look for, though, is that there's a GCF in this problem. It appears that there's actually a 10x as the GCF. So I'm going to divide 10x from both terms. When I do that, I'm left with 2x minus 1. That would be our fully factored form. So now all I have to do is take each factor, the 10x and the 2x minus 1, and set them equal to 0. Now I solve for x. I'm going to divide by 10 to start. I'll get x equals 0 is one solution. And then I'm going to go ahead and add 1 to both sides. I'm going to have 2x equals 1, divide by 2, and the other solution is x equals 1/2. So there's one practice. The practice is attached to your notes for the zero product law, solving quadratics. There is a second practice posted on Canvas, the files, the key, and there's a partial practice video. If you have other questions, come on into office hours and ask your instructor for help.